Hello students, today we are going to study equilibrium in physical processes. When we are saying about the equilibrium in physical processes, in order to explain it, it's best to explain with the phase transformation process. So what is this phase transformation process? It means what? Changing of solid into liquid, liquid into gas, gas again into solid. Okay, these are what? The transformation phases. Okay, so first we are saying what? Solid to liquid, in which solid and liquid will be coexisting in this equilibrium position. Okay, the best example we can take it of ice. Okay, and ice in both solid form and in liquid form. Okay, what happens when does this ice change into its liquid form? Starts changing. We have studied it is at 0 degrees Celsius. So at this particular temperature, okay, this 0 degrees Celsius, for the case of water in the form of ice, okay, form in the solid form, okay, it is known as what? Normal melting point or normal freezing point, in which it is being changed into the liquid form. So at this particular temperature, that is the 0 degrees Celsius or 273 degree Kelvin, okay, this solid and liquid is coexisting. It is in the equilibrium position. Okay, so here we are saying that yes, the melting of the solid into liquid and being in the equilibrium position, and that is at a particular temperature which is known as what? Normal melting point or normal freezing point. Okay, now next is the liquid being changed into gaseous form. It is what? The vaporization. Here we are seeing what? We can take again the example of water. Okay, but here we will be performing an experiment. Okay, we will be taking a glass box. Okay, which is totally transparent in nature. Okay, and what we have kept in that? Anhydrous calcium chloride. Why we have kept that anhydrous calcium chloride? In order to absorb all the water vapors or the moisture present in that glass box. Okay, and it has been attached to a manometer in order to record the pressure. Okay, so now here all the vapors have been absorbed by what? Anhydrous calcium chloride, and yes, the pressure has been noted down. Okay, now what we are doing, we are keeping water in that. Okay, you can take any liquid. Okay, it is not that only you will take only water, you can take any liquid, but for your understanding I am taking what? Water in that. Okay, and just what we are doing, we are increasing the temperature. When we are increasing the temperature, we are seeing the pressure is also increasing and the liquid is being changed into gaseous form. Okay, a time come, okay, in case of water, we are seeing that yes, at 100 degrees Celsius and 1.013 bar pressure, this gas form of the water and the liquid form of the water both are coexisting, and this is here known as what? The boiling point. Okay, and here if we see at high altitudes, what happens? We see the pressure is there low, isn't it? So boiling point also is also low at the high altitudes. Okay, now taking the example of the solid to the gaseous form. Okay, here we can say what? Sublimation comes over here, where solid and gaseous forms are coexisting. Okay, for this we are taking an example of a glass jar box. Okay, glass box, and we have kept iodine crystals in that. Okay, after sometimes we are seeing what? Violet vapors coming out of the this iodine crystals. Okay, and yes, a time comes where there is no change in the intensity of this violet vapors. Here the intensity remains same, as well as the, we can see the crystals of iodine also is same over here. So here at this position we can say that yes, the equilibrium has been achieved. This is how we can explain the phase transformation process. Okay, and this is a physical process explaining equilibrium. Now let us sum up the general characteristics of the equilibria involving the physical processes. Okay, whatever we have studied now, we will be just summing up the characteristic features of this equilibria. Okay, first, equilibrium is always in the closed system. It can be attained very easily in the closed system. If it is an open system, it won't attain equilibrium so easily, isn't it? All the examples which we have taken in a what? Closed glass box, isn't it? Now, both the opposing processes occur at the same rate. Okay, suppose if the water is being changing into water vapors. Okay, so both water vapor as well as water. Okay, they both are what at the same rate. It is not that the more amount of water has been changed into vapor form or more vapor form is being changed into the water form. Both the opposing rates will be what? Similar. Okay, and as the result, if it is similar, here we can't say the reaction has stopped. The amount of water which is being formed in the vapor form, okay, from that also what water is being formed. So it is in a process. So it is what? Dynamic in nature. But yes, even though it is dynamic in nature, it is a stable condition. Okay, now all the measurable properties which we are seeing over here are constant, like temperature, pressure, number of moles. Okay, if we disturb these properties, then equilibrium won't be attained. Okay, now this equilibrium, when it is attained under fixed parameters like constant temperature, constant pressure, okay, and so on. Now, magnitude of such quantities at any state indicates the extent to which the physical process has proceeded before reaching equilibrium. So what does this mean? Actually, we have taken certain amount, okay, and it is being changed into another state, okay, and when it is being said how much it is being changed at that particular time, as others, if we are taking the fixed number of moles, okay, they represent the fixed position at which the equilibrium can be attained, and if we are doing the experiment and how much it has been taken, what is the magnitude of that such quantities, it determines yes that yes how much the reaction has been proceeded before reaching what? The equilibrium. Now let us study equilibrium in chemical processes known as what? The dynamic process. The reaction is going on and we will be understanding this with the help of these three graphs. Okay. So first graph we have taken, along the x-axis we have taken time, along the y-axis we have taken concentration. Okay. And the reactants are the A and B and the products are C and D. So how it is being, you can see from the graph. Okay. See. Initially, the concentration of this A and B, the reactants, is more, isn't it? And then it is going on decreasing and then it is being constant, isn't it? And then we are seeing that yes, this A and B, actually these are reacting to form what? The products. Okay, so initially you see the product is what? Very less, isn't it? But yes, it goes on increasing and at a certain time it comes that what? It attains a constant position, and this position is now known as what? The equilibrium position. Okay, so here we can see the amount of A which is being converted into the C and amount of C is being converted into A, or we can say the amount of A plus B which is being converted into a C plus D, that is the product, is what? From C plus D it is again being converted into A plus B, and as the result it becomes constant and it attains a equilibrium position. Okay. See the second graph. In the second graph we have taken time along the x-axis and we have taken molar concentration along y-axis. Again concentration is only there. Here we have taken what? Nitrogen and hydrogen, and you know this N2 and H2, they react to form ammonia, isn't it? But along with this we have also taken an isotope of hydrogen, that is deuterium. Why we have taken deuterium? In order to analyze the reaction, okay, in the equilibrium position. Okay, so we are seeing what? This N2 and H2 is reacting and it is forming NH3, and yes, it is obtaining a dynamic state or equilibrium state. Here we can say that because this can be analyzed by the radioisotope of what? Deuterium. By the spectroscopic method we study that, we see that yes, the amount of deuterium now which has been formed in the product side, it is coexisting with the reactant side. Likewise, the NH3 which has been formed and the N2 and H2, the reactants, they are coexisting in nature. Okay. Now coming to the third graph. Okay. Here this time is represented again in the x-axis and concentration along the y-axis. You can see from here in this H2 and I2, okay, first the concentration is more and then it goes on decreasing. Okay, and when we see about the HI also, we see it is the concentration is increased over here, and along with the time it decreases. Okay, actually we are seeing this in the reaction both in the forward side also and backward side also. Forward side means what? H2 plus I2 is forming what? HI, and backward side what it is? HI being forming H2 plus I2. Okay, naturally, so here again I am saying you the concentration in the reactant side initially it was more, and then it goes on decreasing. HI, once it has been formed, the concentration is more, and then again it goes on decreasing. So this area totally represents what? The equilibrium position. Okay, so in this three graphs, we can understand by these three graphs the equilibrium in the chemical processes. And this is all for today. Next class we will be studying about the laws of these chemical processes. Okay, good day, take care.